In June 2024, a rocket launched by China crashed dangerously close to villages, marking the latest incident in a series of hazardous booster landings. This was the first stage of a Long March rocket, the backbone of China's space program. While the West often focuses on NASA and the European Space Agency, China's space activities, marked by both remarkable achievements and questionable practices, have increasingly drawn attention. Rockets plummeting onto populated areas, releasing toxic orange gas, are not accidents but intentional outcomes of China's launch strategy. These incidents highlight a space program that, while achieving milestones like launching its own space station and landing on the lunar South Pole, operates with engineering decisions that raise global concerns. China's choice of launch sites is a key factor in these incidents. With an extensive coastline ideal for launching eastward, benefiting from Earth's rotational boost and allowing rocket stages to safely fall into the Pacific Ocean, China instead primarily uses the Xichang Satellite Launch Center, located deep in a mountainous central region. This decision stems from military strategy. Originally built as missile testing bases, these inland facilities were placed far from borders to shield them from potential attacks. However, launching eastward from Xichang sends rocket stages over densely populated rural areas, putting villagers at risk with every launch. The consequences of this approach became tragically clear in 1996, when the U.S. contracted China to launch a telecommunications satellite from Xichang using a Long March 3B rocket. A faulty inertial measurement unit caused the rocket to veer off course shortly after liftoff, crashing into a nearby village. The Chinese government reported 6 deaths, though this figure has been widely disputed. Beyond immediate casualties, these crashes pose long-term health risks due to the toxic propellants used in Long March rockets. Many Long March rockets, particularly models 1 through 4, rely on hypergolic propellants like unsymmetrical dimethylhydrazine, UDMH, as fuel and nitrogen tetroxide as an oxidizer. Hypergolic fuels ignite spontaneously upon contact, eliminating the need for an external ignition source, which ensures reliable ignition for orbital maneuvers. They also remain liquid at higher temperatures, making them suitable for long-term storage, as seen in systems like the Space Shuttle's orbital maneuvering and reaction control systems. However, these chemicals are highly toxic. Nitrogen tetroxide, which produces a distinctive orange hue in the exhaust, forms nitric and nitrous acids when exposed to water, damaging lung tissue and potentially causing permanent scarring or death. UDMH, meanwhile, is a known carcinogen and highly reactive with metals, posing additional health risks. NASA implemented strict safety measures, such as exclusion zones and large fans to disperse toxic fumes, but China's approach lacks similar precautions, effectively exposing rural communities to hazardous chemical fallout. The Chinese government provides minimal warnings to villagers, advising them to adjust their location quickly if they see objects falling from the sky. This cavalier attitude has drawn international criticism, positioning China as an outlier in the global space community. In 2007, China's destruction of one of its own satellites with a missile, a demonstration of military capability, prompted the U.S. to enact the Wolf Amendment, banning NASA from direct cooperation with China's space program. This exclusion from projects like the International Space Station, ISS, may have spurred China to accelerate its independent efforts. Undeterred, China developed its own space station program. In 2011, it launched Tiangong-1, a small prototype station crewed for just 20 days over 2 missions. Originally planned for deorbiting in 2013, it remained in orbit for 5 years to test component longevity. Tiangong-2, launched in 2016, advanced technologies like refueling and cargo transfer, paving the way for a permanent station. Between April 2021 and October 2022, China constructed the Tiangong Space Station, a 3-module structure roughly half the length and 40% the weight of the ISS. Equipped with 2 robotic arms, one 10 meters and another 5 meters, capable of combining into a 15-meter arm, Tiangong represents a significant achievement. To support this ambitious project, China built the Wenchang spacecraft launch site on an island in southern China, enabling launches over the Pacific Ocean. Alongside this, they developed the Long March 5, a heavy-lift rocket designed to reduce reliance on hypergolic fuels. Its main configuration, used for geosynchronous orbit missions, employs kerosene and liquid oxygen in the first stage and liquid hydrogen and oxygen in the second, with 4 liquid oxygen and RP-1 boosters. This rocket can carry 14 tons to geosynchronous orbit. However, the Long March 5B, designed for low Earth orbit, presents a different problem. Lacking a second stage, its 21-ton core stage reaches orbital velocity and remains in orbit for days before drag pulls it back to Earth. Unlike smaller upper stages that burn up on re-entry, this large core stage re-enters uncontrollably, posing risks to populated areas. Between 2021 and 2022, 3 such uncontrolled re-entries occurred during Tiangong's construction, ranking among the largest in history, surpassed only by the Columbia disaster, Skylab, and Salyut 70 orbits. Debris from one re-entry landed in the Ivory Coast, and another prompted France to close airspace over Corsica while European cities were alerted to potential hazards. NASA's administrator has criticized these uncontrolled re-entries, urging spacefaring nations to minimize risks and increase transparency. While the probability of debris hitting densely populated areas is low, the decision to allow 21 tons of metal to fall without control is widely seen as reckless. Despite these controversies, China's space program has achieved significant milestones. In response to U.S. restrictions on GPS access in the 1990s, China developed its own Beidou navigation system. Starting with 4 geostationary satellites between 2000 and 2003, it expanded to 65 satellites by 2020, creating the world's largest positioning constellation, twice the size of the U.S. GPS network. Unlike the one-way communication of GPS, Beidou uses two-way communication, allowing satellites to track receiver locations. While this could aid in locating missing persons, it also raises privacy concerns, particularly in authoritarian contexts. Taiwan, for instance, banned Beidou use for maritime navigation, citing fears of Chinese military surveillance. China's planetary exploration efforts are equally impressive. In May 2021, the Tianwen-1 mission successfully landed a rover on Mars, making China the first nation to achieve this on its initial attempt. The rover's ground-penetrating radar detected polygonal structures 35 meters beneath the surface, potentially indicating water ice from freeze-thaw cycles. China's lunar program, starting with the Chang'e 1 and 2 orbiters in 2007, produced high-resolution 3D lunar maps. Chang'e 3 and 4 landed rovers, with the latter exploring the moon's far side, a global first. Chang'e 5 and 6 returned lunar soil samples, including the first from the far side, and China plans to build a lunar research station. China is also embracing private space companies, with 78 now operating. A notable incident in 2024 involved Space Pioneer, a private firm whose static test inadvertently became a launch, highlighting both progress and challenges in China's commercial space sector. Competition has historically driven space innovation, and China's advancement suggests it is a formidable player. Western media coverage of China's space program often carries bias, emphasizing incidents like rocket crashes while downplaying achievements. Balancing these perspectives is challenging, as journalists must navigate tight deadlines and preconceived narratives. For instance, discussing Beidou's two-way communication raises valid concerns about surveillance but could be contextualized with examples of Western tracking systems. Ultimately, readers benefit from tools that highlight bias and provide transparency. Ground News, developed by a former NASA engineer, offers a solution by analyzing news stories for political leanings, factuality, and ownership. For example, coverage of the 2024 Space Pioneer accident showed 69 outlets reporting, with 36% leaning left and 33% leaning right. Left-leaning sources focused on factual reporting and China's broader space successes, while right-leaning ones used dramatic language. Ground News blind spot feed highlights underreported stories, helping readers uncover narratives obscured by political bias. This tool empowers critical thinking by providing data-driven context, making it easier to navigate the complex landscape of modern news. China's space program, with its blend of audacious goals and risky practices, demands global attention. Its achievements rivaling and sometimes surpassing those of Western counterparts demonstrate ambition and capability. Yet, incidents like uncontrolled rocket re-entries and toxic propellant use underscore the need for greater responsibility. As China continues to expand its presence in space, balancing innovation with safety will be critical to its role as a leading spacefaring nation.